This slide and the next few slides are about defining an expression. The expression keyword defines an expression for reuse within the statement. This avoids cutting and pasting complex expressions. The expression keyword is at the start of the statement. The syntax is the expression keyword, then the expression name, then curly braces, then the expression body, then the rest of the statement. Using the expression keyword alone makes the expression a part of the statement and other statements can't use the expression. The expression body allows parameters and returns a value of any kind. For instance, this query outputs 2 times the constant pi when a withdrawal event arrives. Expression 2 pi. Curly braces. Math.by times 2. Select 2 pi. From withdrawal. The 2 pi expression is part of the statement and can be reused in any expression of the same statement. Other statements do not have access. The create expression keywords define an expression for reuse by other statements. The syntax is create expression, expression name, curly braces, expression body. The expression becomes an EPL object like event types, defined with create schema, named windows, defined with create window, tables, variables, etc. Visibility rules were explained earlier. Use at public for global visibility. To illustrate, the first statement defines the 2 pi expression. At public, create expression 2 pi. Curly braces. Math.by times 2. The next statement outputs 2 times pi when a withdrawal event arrives. Select 2 pi parenthesis. From withdrawal. The 2 pi expression is a separate statement and the expression can be reused by any other statement. The expression can have parameters. The parameter syntax has an arrow, either dash greater or equals greater. The arrow reads as goes to. The parameter syntax differs whether there is a single parameter or multiple parameters. The syntax for a single parameter is parameter name goes to expression body. For instance, expression times pi curly braces factor goes to factor times math.pi. The syntax for multiple parameters requires parenthesis. Parenthesis parameter name optionally comma and additional parameter names goes to expression body. For instance, expression times pi curly braces parenthesis x comma y goes to x times y times math.pi. The compiler determines expression parameter types and compiles the expression body considering parameter types. For instance, the following statement is not valid. Invalid query: the factor value that is passed to the expression is a string type value and a string type value cannot be multiplied with math.pi. Since the query is invalid, we'll skip it. Expression parameters can be events. The compiler determines the return type and it is not necessary to define a return type. The expression math.pi returns a double type value. Subqueries are also allowed in the expression body. The runtime can avoid recomputing expressions by caching computation results. The event types for the examples are create schema market data event parenthesis symbol string comma buy big decimal comma sell big decimal create schema news event parenthesis sentiment double This sample query has an expression that takes a single parameter. The query outputs the midpoint between the buy value and the sell value. Expression mid, price. Curly braces. X. Goes to. Parenthesis. X.buy plus X.sell. Divided by 2. Select mid, price. Parenthesis. MD. From market, data, event. As MD. Above passes the event itself to the expression, as X, and X.buy obtains the property value of the buy property. The next sample query has an expression that takes 2 parameters. The query outputs the buy value of the last market data event multiplied by the sentiment value of the last news event. Expression weighted, sentiment. Curly braces. Parenthesis. X. Comma. Y. Goes to. S.buy times Y.sentiment. Select weighted, sentiment. Parenthesis. MD. Comma. News. From market, data, event. At last event. As MD. Comma. News, event. At last event. As news. This statement defines an expression that has a subquery. This statement defines an expression that fetches the last price. The expression accepts a symbol and a direction as parameters. Assume that last price win is a named window that holds the last price values. The definition of the named window is not shown here. At public. Create expression price subquery. Curly braces. Parenthesis. Symbol. Comma. Direction. Goes to. Parenthesis. Select price. From last price win. As mywin. Where. mywin.symbol equals symbol. And. mywin.direction equals direction. The below statement calls the expression that is defined above. It outputs when a market data event arrives, the buy price and the sell price. Select. Price subquery. Parenthesis. Symbol comma quotes sell. As sell price. Comma. Price subquery. Parenthesis. Symbol comma quotes buy. As buy price. From market data event. This page is an introduction to defining a script. Defining a script allows adding imperative code. The scripting language is typically one of these: JavaScript, GroovyScript. The scripting language can be any scripting language that supports the JSR 223 standard. The expression keyword defines a script, the same as defining an expression. Write, create expression, to allow other statements to use the script. Note, the script executing engine that executes the script is not a part of Esper. Script execution can be disabled as scripts can be a security concern. The syntax is: optionally, the create keyword. Then, the expression keyword. Then, optionally, the return type. Then, optionally, the dialect identifier and a colon. Then, the script name. Then, optionally, parenthesis and a list of parameter names. Then, the script body in square brackets. The optional return type is the return type of the script. The optional dialect identifier, followed by colon, provides the scripting language name, for instance, JS for JavaScript. The configuration can provide a default dialect. The optional parameter names is a comma-separated list of parameter names, in parenthesis, and without parameter type information. The script language body is in square brackets. This example has two statements. The first statement defines a script in the JavaScript scripting language. The second statement computes a value by calling the script. The below assumes that a JavaScript script engine is available in the environment. The first statement declares a publicly reusable script that returns the Fibonacci number for a given number, implemented in JavaScript. At public, create expression JS fib parenthesis num square brackets the JavaScript script that computes the Fibonacci number is below square brackets. The next statement outputs the Fibonacci number of the withdrawal amount. Select fib parenthesis amount from withdrawal. This slide and the next slide discusses defining an inline class. Defining an inline class allows adding imperative code. The inline class is a Java class, or C# class for Microsoft Net. The compiler compiles the class to bytecode and packages it as part of the deployment. The syntax is optionally the create keyword, then the inlined _ class keyword, then double quote, then the class text, then double quote. Specify the create keyword to make the inline class an EPL object that is accessible to other statements. The same as defining an expression as discussed in the beforehand slides. The class text is delimited by 3 double quotes. A package name is not allowed. The class must have public visibility. Inline classes can be disabled as they can be a security concern. These two statements give you an idea of how to use inline classes. The first statement defines an inline class. The second statement uses the class. The first statement defines an inline class myUtility that has a mid-price method that computes a midpoint between two values. The 3 double quotes are the delimiter for the Java code. At public, create inlined _ class. Double quote. After that is the Java code that defines the myUtility class. After the Java code is double quote. The next query outputs the midpoint price for each market data event. Select star, comma, myUtility.mid price, parenthesis, by, comma, sell, as mid, from market data event.